Chapter 3, Episode 1 is about errors or uncertainties in measurement. There is no perfect measurement. Of course, in every measurement, there are some limitations. And here, errors doesn't always mean mistakes. So again, errors are, on this context, are simply deviation or distance of the measured quantity from the actual value. So it's a measurement of accuracy, how much our measured values are from the true or the actual value. Now we have two types of errors. It can be random or systematic errors. Now systematic errors are consistent errors either by a fixed amount or by a fixed proportion. So for example, when your measurement is always 1 gram above the true value, or when your measurement is about 5% above the true value. So these are systematic errors. Again, these are consistent errors. So if you repeat the experiment, you'll get the same error. On the other hand, random errors are random. So random, it means these are inconsistent errors and these are unpredictable. So it can't be replicated by repeating the experiment again. Now systematic errors are in the same direction, either above or below the actual value. Then errors in the random errors are in random directions, can be above and below the actual value. Again, for systematic errors, it's just one direction. It's either above or below the actual value. Then for random errors, it can be above and below the actual value. Let's emphasize this using this example. So let's say you want to measure the weights on this balance. So let's say this one is the true value here. This is 10 grams. Let's say on your first measurement, that is 10.02. So that is 0.02 above the true value. Let's say you add another one that's 20.02. That's still 0.02 above the true value. So this one is consistent because again it's always 0.02 above the true value. Now this one is a systematic error. Again, systematic errors are consistent errors. Now in this case, the cause is, or the source is, zero or an offset error. It's a type of error where the instrument isn't set to zero when you start to weigh the items. So, diba, as you see here, even if it's empty, it's reading as 0.02 grams. So this one is again a zero or an offset error. Now let's have this time. So this time it's now set to zero. Now let's measure again. So the first measurement is 10.01. So now you would like to repeat it again because baka there are some air that is forcing on the balance, or maybe there are some vibrations during your weighing, or there are some dust on the balance. So you want to repeat the measurement again. Let's say this time it's now 9.99 grams. Then you want to repeat the measurement again. Now we have 10.01 grams, and then let's say 9.99 grams. So this is a summary of your measurement, for example. So your first measurement is 10.01. That's 0.01 above the true value. On your second measurement, that's 10. On your third measurement, 9.99. So that's 0.01 below the actual value. Then on the fourth, that's again 10.01. Now this one is a random error. So as we see here, so sometimes it's above the actual value, sometimes it's below the actual value. So again, errors in random directions, these are random errors. Again, it can be above and below the actual value. So again, this one is a random error. Now this one is a plastic measuring tape. So let's say over time, this tape has been stretched. So of course, this would cause errors in the measurement. So let's say your length is actually 2 inches, but the reading is 2.10 inches. So that's about 105% from the true value. Then let's say on your second measurement, yung actual na length is 3 inches, but the measurement you get from this one is 3.15 inches. That's again 105%. Then another measurement, let's say you are measuring a 4 inches na object, then the measurement is 4.20 inches. That is again 5% above the true value. So here we have consistent proportion. It's always 105% from the true value. So this one is a systematic error. Again, these are consistent errors. So these are errors by the same proportion. Now this one, let's say you want to measure the time it takes for a ball to drop on the floor from a height of 5 meters. So let's say your first measurement is zero point 0.9 second, next 1.2 seconds, 1.0 seconds, 1.1 second, then 1.3 second. So obviously this one is a random error because here again, let's say the actual value is 1.0 second. So here sometimes above, then sometimes below yung actual measurement. Now what do you think is the cause for this random error? So of course, in this case, this will just depend on the reaction time of the one that is starting and stopping the watch. So of course, sometimes let's say fast yung reaction, then sometimes slow yung reaction ng naga-stop and naga-start ng watch. So this one, this error is caused by the reaction time of the one measuring the time. So let's try to identify this one, whether it's random or systematic. Weighing an apple in a digital balance gives you readings 12.02 grams, 12.00 grams, 12.01 grams. The true value is 12.01 grams. So again here, that's the true value. Sometimes it's above and sometimes it's below the true value. So this one is a random error. Now again, random errors, these are present in all measurements. So in this case, it may be caused by there are air that is forcing on the balance, or maybe there are vibrations, or maybe there are dust, or maybe the machine is there are some overheating on the machine at this time. So again, random errors are present in all measurements, and this cannot be eliminated, or in some cases, this is hard to eliminate, or it's hard to eliminate. It's caused by uncontrollable factors that affect the experimental results. It's reduced by repeating the measurement, then averaging them. So for example, here, this one is a balance. So again, sometimes let's say 10.01, sometimes 10.02, then sometimes 9.99.